Hello everyone, welcome back to the channel. So now given a Codeforces Round 11101 Div 2, let's understand, discuss the solution of this particular contest. I was able to solve ABC, like C of C1. So let's discuss how do we actually approach these problems. So if we see the A problem, so the A and B problem was easy for that, and C was actually quite a difficult and tricky problem. So we'll see all of them. So A problem is saying that Alice is inviting her friends to eat, okay, and for a particular index I, it chooses some indexes and calls two persons, okay, and do the minimum and okay, and yeah. So if I give you the explanation of what the problem is saying, so the problem is saying that Alice can make some group call or so, but it cannot make a group call to all of the users. So what he's doing is, so he picks some values I and j, right, and what he can give a coordinate to the both persons is that ai of aj, like it should be in the range of this particular minimum and the maximum of ai and aj. So and if we see the constraints as well, so n is going till 100 and t is 500. So like I think the constraints are pretty on the lower side, so we could directly go with the brute force approach. So what the brute force approach actually says, or the, you can say a naive approach I would say. So brute force actually says for each particular index I, let's take this as my target position, like this as my target position where all of the persons would be reaching. So for this particular person, I'll see how many persons are towards its left and how many persons are towards its right. So whichever would give me the net minimum, I would say net minimum, that for which I have to make the minimum number of calls, that would be my answer. Like I would be iterating for each of the possible I. So my time complexity would be t into n. Now let me show you the code as well. What I'm trying to say is, so what I'm saying is, yeah, so ignore this map kind of a thing. Like I was writing something, but I was like not able to remove it, so I just make it as it is. So what I've taken is, I've taken the input and I've sorted the array. Like the reason behind sorting the array is, like, as you can understand that if I take the minimum element from the start and the maximum element from the end, my all of the element, like the minimum and the maximum range, the minimum and the maximum range would actually lie between these minimum and the maximum only. Like they cannot exceed beyond this, or like cannot go beyond this. So that's why I've sorted the array. So and also what I'm doing is, for each particular I, I'm just checking whether, assuming that a of I is my target element, I'm counting how many elements are towards its left and how many elements are, like elements greater than elements lesser towards its left and towards its right. So if left side elements are greater than that, so I know that I have to make this much number of group calls, I would say, to bring, and so the I'll just update my answer, the minimum of that answer, and simply that would be my answer. So this is how you would be able to solve the A problem. Now let's move to the B problem. B problem was also very easy. So easy in terms of, let's discuss what the B problem is saying first. So the B problem was saying that Alice is having some kind of a cake, right? And there are different frosting levels to this particular cake, right? Some kind of this. So she goes from this left hand side to the right hand side, and now what she's wanted is, we need to find a certain h for each of the possible I, that particular h is actually the maximum possible frosting height it could she could maintain. So what do we mean by the frosting height is, let's suppose I'm having a frosting height at initially is 4, then it's initially 3, then it's 2. Example, this is my, so if I consider this particular element, so if I having only a single element, so my frosting height would remain 4, yes or no? Now if I take the consideration in the case of 4 and 3, now if I take a frosting height of 3, right, my next height, like this particular extra one block element would move here, right? So it would actually become something like 3, 4, right? Now when I will be moving to the next block, I would be thinking this is some kind of an excess element for me, I'll just remove that, right? So it would actually be this and this, So this is actually the maximum frosting height I could maintain, so that all of the elements are on the same page. Like I could go for the 2 as well, like 2 or 1 are also possible, but I need to find the maximum possible h that is there. So 3 would be the answer for this. And similarly, if I consider 4, 3 and 2, so in that case 2 would be my answer, right? So my net answer would be 4, 3 and 2, right? So if we see, so like I've just reversed this particular case, so it's here is 4, 2, 2, but if you take 4, 3, 2, it would be 4, 3, 2. Now if you say, now the question is, how do we actually solve this problem optimally, right? Okay, I would say like try to think this problem as a bit of a mathematical side, right? So let's take, if I take something a of I, right? I'll not take a of I, let's take the first element as of now. If a of 1 is greater than h is the frosting height I'm maintaining. If a of 1 is greater than h, then I would be knowing that my excess, like my remaining would be a of 1 minus h. This would be actually my remaining, right? The remaining height, if h is the height I'm considering, let's suppose this was my h in this particular case. My h here was 3. So 4 minus 3 is actually 1, which is actually my remaining height. And this particular 1 would actually carry forward to a of 2. Yes or no? So if this particular thing is carry forward, so if I take the new height, so new height at the next moment would be a2 plus this particular excess, so this particular excess of 1. And similarly I'll just again remove h from here, right, assuming this particular thing is greater than h. And similarly for a3 it would be excess of 2. Yes or no? So in this particular fashion we'll go and we'll see further. Now if we see it in a bit of a mathematical way, so now if I'm taking k positions, okay, now if we are dealing with k particular positions, now can I say that s of k is actually the prefix sum till k elements, right? So to maintain a frosting level of at least height of h, my sk should be greater than equal to k into h. This should be the case, right? This should be the minimum case. If I need to maintain a frosting height of level h, I should at least my sum should be greater than equal to like product of this particular elements. Yes or no? Now if I say my h would simply be less than equal to s of k by k, given for a given k elements, right? For a given k elements. Now what I need to find is, I need to find some like maximum possible h, which could be my possible answer for each of the I, like, right? So what I'll be doing is like the maximum possible h for a particular, I would say I, so that would give you from here, like this would be the maximum possible h, but for all of that you need to find the minimum. Like if I go you with this particular, like h of I, like for the IS index I'm talking about, so it would simply be s of 1 by 1, s of 2 by 2, s of 3 by 3 till s of I by I, and for all you will take the minimum, right? For a particular k elements your h would be the maximum possible over here, but for when you are taking the considering all of the HIs, you need to take the minimum, right? So this is how you would be like solving this particular problem. Now let me walk through the code as well. So if you see the code as well, so here is the code. So for each particular you'll define an answer int underscore max, then you'll find the sum. For each particular I, you know the sum till I, it would simply be divided by here, and if your h is less than answer, your answer would be h, you simply print the answer. So this is how you will be solving this problem. Now let me discuss problem C1. C1 was actually a good problem, so we'll start discussing this problem. Okay, so now let me explain you what the C1 problem was saying. C1. So C1 problem was saying that you are having x number of tables and s seats for each of them, and also okay, and there are some n people which come to your party, and for these n people we have three kind of people, I, E and A. for the I, like the introverts, the categorization always set on empty table, like always set on empty table, always set on fill table, always set on table with greater than 0, like greater than 0 elements, and both are possible for them, right? So now the question is, how do we like we need to actually maintain the maximum number of people we can keep to the party if let's suppose we don't have any new tables to fill in, so all of the I's or all of the introverts won't be able to access the party. Same for the extroverts, if we don't have any table which have more than one person, so extroverts would also not come. But for ambiverts we'll say the same thing, like if they don't have the seats or something, so it would be the case. Now if you read this problem very carefully, it would be giving you an idea of that it would be a DP problem, right? Now if I maintain some DP of I, which I'll define as maximum number of people we can seat given I tables, right? So your answer would be the maximum of this particular DP, not DP but DP, right? Now let's understand the transition state. Like, so we know that to attempt DP, like it would be simply two basic things we need to understand. One is the DP state and one is the transition. If we are comfortably able to make them, then we'll, like, this problem is pretty easily solved for any DP problem. Okay, so now let's understand how does my transition would look like. So if I talk about the introverts first, or simply I'll write I, right? So we know that they would always take a new table, like always we must have an empty table, like, or rather we could say always take a new table, okay. So if you if your current tables, let's suppose your current tables are I, is less than X, right? Like you have the access to all of the tables, like your current table is less than X is the total number of tables, then you can know that you would be having, like you could consider the request of placing introverts to a new table. So in that case I would be maintaining a DP1. The reason I'm maintaining a DP1 here is, let me write that, it would be the max of DP1 of I plus 1, comma, here I write DP of I plus 1. Okay, the reason I'm writing DP of I, like DP1, this is a temporary DP, this is actually a temp DP. DP1 is actually equal to DP. So this particular DP1 is actually storing the state of the original DP array for a particular person. Like this DP array would be actually be working for a single person to maintain the all of the personalities and also maintaining the state of not considering anyone. Like I'll show you in the code as well. You'll able to understand better in the code. Just hang on for a second. Just see the transitions of what I'm explaining you. So here DP of 1 would something like this. Now if we talk about extroverts, so if we talk about the extroverts, what I want is to extroverts that we need to have space, right? So on what case I would say that if I'm I tables, then total seating capacity is I into S. This would be my total seating capacity, yes or no? So if your current is actually less than this particular I into S, right, then you simply do is DP of I would be equal to max of DP1 of I, comma DP of I plus 1, yes or no? Because the DP of I would be telling you maximum people, like this would actually be your current, because this would be telling you what is the maximum number of people you can adjust using the I tables, yes or no? Now if we talk about the ambiverts, so for ambiverts we have both of the options open. For ambiverts both of the options are open, so we'll see whichever we would take, will take both of the options for ambiverts. So if let me drive you through the code as well. the code which I'm trying to make is, so if you see from here is what I've done is I've initialized the DP array of the total number of tables, initialize them to -1. Now for each of the particular person, I'm maintaining a DP1. DP1 is the actual state I'm maintaining. For each person, what I'm saying is, if your current personality is introvert or ambivert, you have a possible option to take the case of like opening a new table. For in that, if your current plus 1 is actually greater than DP of 1 plus I plus 1, then so if your I is less than X, means you have the capacity to take the tables, you are simply taking the maximum of both of them, right? If your personality is some kind of a extrovert or an ambivert, then could be a possibility that you could opt out for a already existing table. In that case, I should be greater than 0, like your table should be positive, and your current space, like the current, I would say the seating capacity, should be I into S, should be less than I into S, because this is the maximum packs and here is the maximum capacity, like the maximum packs we could set. So, and here we are taking the maximum, and finally out of the DP array we are taking whichever is the maximum. So this is how you would be solving this particular C1 problem. So yeah, so this is how you would be solving A, B and C1 problem. I tried C2 but actually getting a TLD case. So we'll have a look at it and we'll share you the solution if I was able to solve. So okay, thank you, thanks a lot guys.